Hello there, ladies and gentlemen. Here's a video for section 3.8, which is about parallel and perpendicular lines, dealing with those particularly on a graph, so a coordinate plane, what the slope of parallel and perpendicular lines will look like, how they relate to each other. So make sure this goal is written down on your goal sheet. I can relate slope and parallel and perpendicular line, or to parallel and perpendicular lines. So we're going to start off with filling out a little chart that's nicely placed in your notes for you. Comparing parallel and perpendicular lines. We briefly touched on this with a warm-up a week or so ago, but how they relate with their slope mainly. So this first box actually does have to do with the slopes of parallel and perpendicular lines. Okay, so if the relationship between slopes of parallel lines, hopefully you remember they have the same slope. Does not matter where they start, as long as they're starting at a different point, a different y-intercept, as long as they have the same slope. Perpendicular lines, though, they have opposite signs, opposite reciprocal slopes. So they have to be both opposite and reciprocal slopes. Well, they look like this. You know what parallel lines look like. This should be an easy one to fill in. They never cross, whereas perpendicular lines cross and form 90-degree angles. These two examples are going to be good, though. So it says if the slope is 1/3, the slope of a parallel line, well, the slope would be the same, so it's 1/3. The slope of a perpendicular line would have to be opposite sign. So it's going to be negative, and it's going to be the reciprocal, so -3/1. How about we have -6? Always put it over 1, so that you have the rise and the run. The slope of a parallel line to that would be the same again, -6/1. And perpendicular, hopefully you can do the opposite and the reciprocal. So it was a negative, this time it's going to become a positive, 1/6. Okay? So let's look at this one right here. How can you determine if these two lines are perpendicular? Because they look kind of close, but it's hard to tell exactly if they are perpendicular or not. Well, we want to figure out if line 1 and line 2 are perpendicular. So I think part of this has to do with just finding the slopes. So let's just find the slope of line 1 and line 2. And that'll tell us then if they're perpendicular or parallel or neither. So let's say line 1, we have 2 points here. So let's go from 1, 2, 3 down, 1, 2, 3 over. So we -3/3. This is the slope, by the way. Would be equal to -1 or -1/1. Line 2, let's use these 2 points here. To get from 2 points 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5, 6, 7 over. So that'd be 5/7, which is not the same as -1/1. So slopes are not well, they are opposites, but they're not reciprocal. In this case, since they're not reciprocal slopes, they are not perpendicular, they will not form 90-degree angles. So there's an example using a graph. Next, we have a whole bunch of other examples in which you can, dealing with parallel and perpendicular lines, figuring them out together here without the graph. So I'm just going to put this in here and erase all this. So let's look at a couple of these. I won't go through every single one with you. You got to do some of them on your own. But let's start with number 1. Number 1 says, given points A, B, and C, and D, we have those, determine if line AB is parallel or perpendicular to line CD. So again, we just need to find the slopes. Really, it just matters what the slopes are. So if we have AB and we have CD, Let's find the slope of AB. So let's use the slope formula if we have 2 points. AB, we have the point 1 would be the second y one. So 1 minus negative 2 over 9. And remember, slope formula, m equals y2 minus y1 over x2 minus x1. So we have the 9 minus negative 3, which would equal, those become plus, so it would be 3 over 12, which actually can be reduced to 1/4. CD then, the slope, we can use the 2 points for C and D. Let's do negative 2 minus 6 over 5 minus 3. And you end up getting negative 8 over 2, which reduces to negative 4 over 1. So are these parallel or perpendicular? Well, I would say that they are perpendicular because of the fact that they're opposites and they're reciprocals. So slopes are really just the thing that matters when we're talking about parallel or perpendicular lines. Number 2 says, what is the equation of the line parallel to y equals 2 over 3x plus 3 and contains the point 0, 6? Oh, here's a good one. How could you do that? Well, I can give you 2 different ways to do that. One, I'd say use point slope form. So if you have the slope, we know if it has to be parallel, the slope is going to be 2/3 no matter what. We can plug in the point slope form. Doesn't it say it has to be in slope intercept form? So let's do y minus the y value, which would be 6, equals the slope times x minus the 0. So there you go. There's the equation of that line. Now, the second way that I could do this, and there's, again, variations of this too, but I could just use the equation y equals 2x plus b, because we don't know what our b would be yet, and plug in the point for the x and the y. So we'd have 6 equals 2/3 times the x plus the b. So I'd have 6 equals, well, that's 0. So 0 plus b. So 6 is going to be equal to b. You know, those look probably the same, the b and the 6. But then we can put that back in for our formula, our equation, and keep the slope of 2/3, and then just plus 6. So just take a look again. If you're confused with that, look through it again, see exactly what we did. Using 2 different ways, using the point slope form or using slope intercept form, you can figure out the equation of the line parallel to that. Number 3 is similar but a little bit different. It says, what is the equation of the line perpendicular to 3x plus 4y equals 12 and passes through that point? So you're going to have to find the slope first, no matter what. And then we can just pick one of those 2 methods we did before for number 2. So if I take 3x plus 4y equals 12, I want to solve for y so it's in slope intercept form so I know what the slope is. That's probably the easiest way to figure out what the slope is given that line in that equation. So I'm going to subtract 3x from both sides. So you have 4y is left over here equals negative 3x plus 12. Divide by 4. Divide all the parts by 4. So you end up with y equals negative 3/4 x plus 3. So that's just rearranging that form, that equation, so that we have the slope. So the slope here, we know has to be, well, negative 3/4 is for this line. We want to find a line perpendicular to it. So I'm just going to use that first method again that I used for number 2, where I'm going to use the point slope form. So y minus the y value, which is 3, equals the, perpendicular slope would be opposite reciprocal. So positive 4 over 3 times x minus negative 5, which would be x plus 5. And there we go. There it is. There's other ways to do it. You can use slope intercept form if you'd like. Number 4, I don't want you to think too hard about. We have the line y equals 8, so that kind of, if you look at the graph, that would go something like through the, if this is 8, it would go right through there. So we want it to be perpendicular to that, and we want it to go through the point -3 and 7. So it's going to have to go through the point, through -3. No matter where it is, it's going to have to go through right through the x value of -3. So the line is simply x equals -3. Okay, so don't look into that one too far. Now these two I think are a little bit more challenging. Let's just take a look at them. At least number 5. Let's see. So find the value of x so that the line passes through x and 2 and 3, 5. So the line that passes through that is perpendicular to the line that passes through 0, 1, and 2, 7. I think we're going to have to find the slope. So if we know the slope for the second one, let's just do that. M equals, let's do it for these two. 7 minus 1 over 2 minus 0. Because honestly, I haven't done this one for a while, so I'm trying to think about how we can do it. So let's just start by finding the slope of the one that we know all the points for. So that'll be equal to 6 over 2, which is equal to 3 over 1. So we want this, if we want it to be perpendicular, we want the slope of the other one, so that one was in blue, so the other one is in purple here, to be equal to the opposite, which would be opposite and reciprocal, -1/3. So if these are our points, let's say the slope is, let's just plug it in. 5, oops, 5 minus 2 over 3 minus x. That has to be equal to -1/3. That's interesting. Why don't I take this all and just put it over here? And it looks to me like we have a proportion. So let's do something with that proportion. Because it's two ratios, two fractions set equal to each other. So I'm going to do a little cross multiplying. Actually, first I'm going to change this to 3. 5 minus 2 is 3. I'll do a little cross multiplying. There, and set it equal to there. So then I have -1 times 3 minus x. Whoa. Equals 3 times 3. Let's do, this is going to be 9 over here. This is going to be distributing. You get -3 minus -x, so plus x. Add 3 to both sides. Looks like x is going to be equal to 12. I think that would work then. We'd have we want the slope to be -1 over 3. So let's just check it over here. If this was 12, we'd have 5 minus 2 over 3 minus 12, which would be 3 over -9, which would reduce to -1/3. Hey, hey! That's exactly what we wanted to get. So give yourself a big smiley face on that one. So x would be 12. So honestly, like I said, I haven't even done that one yet this year. I just forgot about doing that one, and I just went for it. Just started doing stuff, and so that's what I suggest to do. Be independent, try to figure things out on your own, and see if it'll work out. All right. Number 6, we'll see if we have time for this one. I'll read it through first. It says a classmate applied the following points: A, which is -3, 2, B, which is -1, 4, and C, which is 1, 2. Where should the classmate point D so that the quadrilateral formed has perpendicular sides? So you're trying to make it um, a rectangle. Now, if I'm looking at a grid, I don't know if this will work out neatly if I kind of do We gotta go up to 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is just a quick sketch just to see if it works out and to see if I don't have to do any extra work. Negative 3 and 2. Negative 1, 4. 1, 2. I guess there's a couple different places you can put it down here. So you're gonna have to make lines parallel or perpendicular, sorry. We're gonna have to figure out this is a long problem, I think. I think you probably have to find distances. You might have to find distances. You definitely have to find let's see, where's it find the final point where the class is. Well, I mean there's a couple different places. I think you have to put it here actually. You have to go down here somewhere, like negative 1 and 1, something along those lines. I don't know if that one would work out because I don't know if these lines would then be, whoops. I don't know if these lines would then be perpendicular. I think this is one that we'll go through together next time we are in class. Okay? What you can do on your own though before class is try to figure out find the area problem and answer the closing question. And then also self-assess yourself on the goal sheet. So let's see you next time.